In this demo, we go through how VMware Security, with its built-in advanced threat prevention and networking detection response capabilities, can detect advanced threats involving a multitude of tactics and techniques used in current ransomware and intrusion campaigns. Here we are looking at the NSX Discovery and Planning page. This shows a high-level overview of existing workload groups and flows between them. Green lines indicate flows that are matching an existing segmentation policy in NSX, while the red dotted lines indicate unprotected flows. In addition to looking at communication between existing groups, we can also look at discovered flows between individual workloads. Let me isolate some of the workloads that make up a couple of multi-tier applications. We can see that some of the workloads have an exclamation mark. This indicates that we've detected a threat affecting those workloads. I can apply additional filtering to only look at the workloads in which we've detected anomaly events that are relatively high in severity. Let me zoom into the production mortgage database workload. As you can see, a number of anomalies have been detected. VMware's Advanced Threat Prevention leverages enhanced NetFlow data as well as endpoint context and Layer 7 flow information to build a baseline of what's normal for every workload. It uses both unsupervised and supervised machine learning with threat-centric models to identify deviations from normal that are security relevant. The detection with the highest threat score indicates that we've detected the use of a domain generation algorithm, which is often employed by malware authors to ensure that command and control traffic remains undetected by next-generation perimeter firewalls that rely on FQDN and IP-based filtering. You can see that there's a campaign link available in this anomaly event. The presence of this link indicates that this atomic event has been correlated with other signals based on detections from our IDPS, malware analysis, or traffic analysis into an actionable intrusion campaign. Clicking on this link brings us to the NDR, or Network Detection and Response view. Here you can see we have detected and correlated much more than just the DGA anomaly on the mortgage database workload. We've detected a malicious file on 3 different workloads. The DGA anomaly that we just looked at earlier, the use of the Empire agent, CryptoWall command and control, the use of an exploit kit, as well as exfiltration using DNSCAT. This raises the impact and risk significantly. We can also see the 3 workloads that are involved in this intrusion campaign, and we map the different detections to the MITRE attack framework. The campaign blueprint provides a graphical representation of how the intrusion unfolded. Let me organize this a little bit. I'm moving the internal workloads that are part of our network to the left and putting the external IP addresses on the right side. Now we can see the different threats that were detected by our IDPS, malware, and anomaly detectors in between these entities. To get a deeper understanding of the attack sequence, we can open up the timeline view. Let me organize this by start time. The first thing we detected is the download of a malicious file to this IP address that belongs to a VDI desktop. We can click on the file name to get additional context, and we can see, for example, that this file has been identified as containing the CryptoWall ransomware and has performed suspicious geolocation queries. From here, we can open up the Analyst Threat Board. Since this file was a zip archive, we've inflated it and extracted its contents. Clicking this link reveals some of the key characteristics we've observed when we dynamically analyzed and detonated this file in our sandbox. Because our architecture is based on full system emulation rather than virtualization, we can detect not just how the program, under analysis, is interacting with the operating system, but we can see the interaction with memory, CPU, and other hardware resources. This enables us, for example, to see if evasive malware is living in memory without actually calling it. This also means our sandbox doesn't rely on the use of golden images for different operating systems or applications. A buffer overflow is a buffer overflow regardless of the application it's exploiting. Let's go through a few of the observations. We can see here that when we detonated this program, that it attempted to evade detection by stopping the Windows Security Center service. We also observed command and control traffic on the network, as well as additional evasions by deleting volume shadow copies. One other observation of interest is this one, which indicates this malware attempted to use a domain generation algorithm for outbound communication. Remember how we just observed this as well in our actual network. Finally, we saw the program attempted to disable endpoint security, which is a common feature of malware. At the same time we detected a download of CryptoWall, we detected an exploit attempt. More specifically, we detected the use of the Magnitude exploit kit on the network. Magnitude exploits various Java and Flash vulnerabilities in an attempt to compromise the victim's computer in order to install malware. The exploitation is attempted when a user is transparently redirected to the exploit kit landing page from a compromised website or through malicious advertisements on benign websites. This was also detected from the VDI desktop and is how the CryptoWall malware was downloaded to the desktop. We can click on any of these parameters, like this IP address from which the exploit kit was served, to get additional context. We can also click on the detector, like in this case an IDPS signature, to learn more about this particular detection. When we click on the IP address of the affected workload, we can see that this is associated with the VDI2 desktop. A few minutes after we've detected the exploit kit and the download of CryptoWall, we've observed command and control activity associated with CryptoWall. This has also been detected by means of an IDPS signature. That was followed 20 minutes later by the detection of an anomalous PS exec interaction between our VDI desktop and another workload in our environment. PS exec lets users execute processes on other systems complete with full interactivity for console applications without having to manually install client software. Now, while these applications may be common in certain network environments, the potential for use in the context of lateral movement makes them worthy of attention. In this case, the frequency of the activity in the network indicates this may be anomalous. This activity was mapped to the lateral movement tactic of the MITRE attack framework and was used by the malicious actor to pivot the attack from the VDI desktop to the target workload with the IP address of 192.168.20.211. Since this is east-west lateral movement within our network, we've detected the same activity at the VNIC of the target workload, which is the prod CRM app 1 workload, a CRM application that is deployed in our production environment. About 10 minutes later, we detected the domain generation algorithm anomaly that we looked at earlier in the discovery and planning view in NSX. This is the atomic event we started our investigation from. This indicates that suspicious domains used by malware were running on our infected machine. These domains were identified using anomaly detection techniques that characterize domain name resolution patterns that are typical of malware using domain generating algorithms. Around the same time, by means of an IDPS detector, we identified network activity related to the Empire agent on the compromised prod CRM app 1 workload. Empire is a post-exploitation framework offering a wide variety of modules that can be used to perform a variety of malicious activities on a compromised host. This is followed by the download of the same malicious file containing CryptoWall on the prod CRM app 1 workload. The next phase of the attack started 12 minutes later, where the attacker used Windows Remote Task Scheduling to pivot the attack once more and target another workload in our environment, the production mortgage app with the IP address of 192.168.20.151. The Windows Task Scheduling utility allows administrators to manage scheduled tasks on remote hosts. In this particular scenario, we have identified a use case that appears to be suspicious given the context. Around the same time, we observed an attempt at credential harvesting using Kerberos ticket granting tickets initiated from the prod CRM app VM to the prod mortgage app workload. On this prod mortgage app workload, we saw additional remote task scheduling, followed by the same domain generation algorithm, Empire agent, and CryptoWall detection we've seen on the other workload. Finally, we detected the use of DNSCAT on the network, indicating exfiltration of data from the prod mortgage app workload. This was confirmed by 3 distinct IDS signatures. We can learn more about each signature by clicking this link, which shows a detailed abstract as well as the actual regex pattern matching expression. Advanced threat prevention and network detection and response are powerful tools in the VMware security framework. These tools can help you not only secure your environment, but provide the essential visibility needed when a threat occurs. Thank you for watching. We'll see you next time.